بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some review exercises about chapter 1. This is a function f of x evaluates the difference quotients. Well, let us find the difference quotients. F of a plus h, we replace x in the function by a plus h. So we will have a plus h to the power 2, then minus 2 times x, so it's also replaced by a plus h plus 3. This is f of a plus h. Minus f of a, we replace x by a, so we have a square minus 2a plus 3, all of this over h. Now we expand, we have a square plus 2ah plus h square. This is a square of a binomial minus 2a, and also minus 2 is multiplied by h, then plus 3. Then this negative sign also will be distributed. Negative a square minus times minus is positive 2a, and negative 3 over h. Now we notice some cancellations. A square with negative a square, negative 2a with positive 2a, positive 3 with negative 3. And then we notice that uh, 3 terms are left in the numerator, and h is a common factor in all of these 3 terms. So here we will have 2a taking h as a common factor, then plus h, we have h square and we took h as a common factor, then minus 2, and h is taken out over h. Now we cancel h with h, and the final answer would be 2a plus h minus 2. That's the difference quotient. Find the domain and range of each function. Write your answer in interval notation. This is a fraction 2 over 3x minus 1. The denominator cannot be 0. So the number that makes the denominator 0 should be excluded from the domain. We can see that the number is 1 over 3. So the domain would be all real numbers except 1 over 3. Or we can write it from negative infinity to 1 over 3 union from 1 over 3 to infinity. Also, if you want to determine the range, you think of the possible values of y. Well, this is y. It's 2 over 3x minus 1. The numerator is 2, so y will never be 0, because whenever you have 0 over a number, this will give you 0. So you only get 0 if you have 0 over a number, which is not 0. So this is 2. So y will never be 0. So you can say that the range of this function, all real numbers except the 0, or from negative infinity to 0, union 0 to infinity. For the logarithmic function, the natural logarithmic function, the domain x plus 6 should be greater than 0. Inside ln cannot be 0 or negative, so x has to be greater than negative 6. So the domain would be from negative 6 to infinity. While this is a logarithmic function, you know the graph of the logarithmic function, the range of the logarithmic function is from negative infinity to infinity. Use transformations to sketch the graph of this function. The original function here is y equals x squared, and we know the graph of y equals x squared. It is a parabola, opens upwards. And now we have 3 units. We have taken the graph of x squared 3 units to the right. So the graph of f of x would be same as this, but taken 3 units to the right. So this would be the graph of f of x. Of course, it doesn't here doesn't go like this. It's a parabola. Okay, so it's a parabola, uh, and this is the x-axis. This function, the original function is e to the power x, the exponential function, the natural exponential function, and we know that this is the graph of the natural exponential function, and the horizontal asymptote as equation y equals 0. Now we have a reflection and a vertical shift. We know that the reflection comes before. This is the order of transformations. So the reflection comes before the vertical shifting. So let us graph the reflection. We multiplied y by negative, so this would be the same graph as this one, but reflected about the x-axis. So the horizontal asymptote will not change, but this one now will become negative 1, and the graph will be reflected about the x-axis like this. Okay, so this is the graph of, let us say, like this. This is the graph of e to the negative e to the power x. And now h of x, we will take this graph 2 units up. And when we take it 2 units up, now the horizontal asymptote will be changed. It would be y equals to 2. And the point -1 will go to the point 1. And this would be the graph of h of x. Uh, he did not ask about the domain and the range, but if you want to find the domain or real numbers, the range from -infinity to open. This is also an exponential function. So the original function is zero point 0.5 to the power x. And since the base is less than 1, the function is decreasing and it goes like this. It passes, of course, by the point by the point uh, 0, 1. Okay, this is the graph of this function. And now uh, 1 unit, we take it 1 unit up. So the graph of s of x would be the horizontal asymptote was y equals to 0. When you take it 1 unit up, it would be y equals to 1. And the y-intercept, instead of being 1, it would be 2. And the graph of the function would be like this. This is a piecewise function, changes its definition around 0. So to the right of 0, the graph is the graph of ex minus 1. To the left of 0, the graph is the line y equals -x. This is a straight line. You need only 2 points to sketch the graph of this line. Uh, if x is 0, y is 0, but 0 is not included, so you keep it open, this one, okay? And if x, you choose another one, for example, -1, to the left, you choose a value of x to the left of 0. So a -1, -1 would be 1. So this would be the graph of this line. And it's a very famous line, the line y equals -x. Now to the right of 0, we sketch the graph of this function. This is the exponential function, and this is the graph of the exponential function. So to the right of 0, it will go like this. But if you take it 1 unit down, so the graph of the exponential would be like this. Now the 0 is included here, and they both pass by this point. So it's a continuous graph, okay? It would be, the graph would be continuous. At 0, it is 0. So this is the graph of the function f of x. Determine whether the function is odd, even, or neither. As usual, we find f of negative x. F of negative x, we replace x by negative x. So, and now negative x to the power 2 is just x squared because uh, square will, negative 1 square will be positive 1. So now this function is equal to the original, is exactly the original function. So f is even. So if we find that f of negative x equals f of x, then f would be even. For this function, let us find f of negative x. It is 1 plus sine negative x. And we know that sine negative x equals to negative sine x. So in fact, sine x is an odd function. So this would be equal to 1 minus sine x. Now 1 minus sine x is not equal to f of x, and it is not equal to negative f of x, because negative f of x is negative 1 minus sine x. So this function is neither even nor odd. Well, here if we find f of negative x, it would be equal to 1 minus cosine 2 times negative x. We know that cosine negative x equals to cosine x, and the cosine is an even function. So we will have 1 minus, and cosine uh, negative 2x, or 2 times negative x, would be equal to cosine 2x, because the cosine is even function. So negative 2x cosine negative 2x is equal to cosine 2x. So this is equal to the original function, and hence f is even function. The last question, if we find here f of negative x, then we have negative x plus 1 to the power 2. This is not equal to f of x, and it is not equal to negative f of x, because negative f of x is negative times x plus 1 to the power 2, and these are different. So f is neither even nor odd. If you want to expand the square of the binomial and check that they are different, it's clear that they are different anyway. F of x is ln x, gx is x squared minus 9. Find the functions f circle g, so on, and their domains. So let us find f circle g of x. F circle g of x is f of g of x, and this is f of, let us put g of x now, which is x squared minus 9, and now we need to find f of x squared minus 9. Well, we go to the definition of f and replace x by x squared minus 9. So this would be f circle g. Now, how to determine the domain of f circle g? We know that the domain of f circle g equals the domain of g intersection the domain of the result. Well, this is g. The domain of g is all real numbers. We don't have a fraction or a square root. For domain of the result, okay, for the domain of the result, x squared minus 9 should be greater than 0. And this is a second degree, a quadratic inequality. So to solve this inequality, you need to find the zeros of x squared minus 9. And the zeros of x squared minus 9 are negative 3 and 3. And if you check 0, which is between negative 3 and 3, 0 minus 9 is greater than 0. This is not correct. Okay. So if you check a number greater than 3 or less than negative 3, it will make the inequality correct. So the domain of the result is from negative infinity to negative 3, union 3 to infinity, open, because we do not accept that the number inside 0 being 0. Okay, so this is the domain of the result, and the domain of G is negative infinity to infinity. So the intersection would give you from negative infinity to 3, union from 3 to infinity. G circle f of x would be G of f of x would be G of, we write f of x, which is ln x. And now we find G of ln x. We go to G of x. We replace x by ln x. So we will have ln x to the power 2 minus 9. Now domain G circle f, as we know, is equal to the domain of f, the second one, intersection the domain of the result. Okay, well, this is f is ln x. So domain f as x should be greater than 0 because we have ln x, so the domain is from 0 to infinity. For the result, we have ln x to the power 2, it doesn't matter. So we have ln x. So again, x should be greater than 0. So the domain is also from 0 to infinity. That's the domain of the result. The intersection would be from 0 to infinity. So this is the domain of G circle f. F circle f of x would be f of x would be f of x is ln x. F ln x would be ln, and I replace x by ln x. So it would be ln of ln x. Now the domain of f circle f should be equal to the domain of f intersection domain of result. We have the domain of f from 0 to infinity. Let us try to find the domain of the result. Well, x should be greater than 0, okay, for this function. And now ln x should be also greater than 0. So we have a condition here, x is greater than 0, and ln x should be greater than 0 because ln of ln x. Well, we know the graph of ln x. It is like this. This is the graph of ln x. For ln x to be positive, it has to start from 1. Okay, so ln x would be 0 if x in fact is greater than 0 if x is greater than 1. So whenever you find ln half, it would be negative. Ln 1 is 0, and ln 1.1 would be greater than 0. So in fact, the domain of the result is from 1 to infinity. Intersection domain f, which is from 0 to infinity. So the domain would be from 1 to infinity. So pay attention to this question. It's a nice idea here. G circle G of x would be G of x would be G of x is x squared minus 9. And now we need to find G of x squared minus 9. Again, it's x squared minus 9. So I replace x by x squared minus 9, which is here, and I raise it to the power 2, and I write minus 9, okay? So I replaced x by x squared minus 9. You can expand this. It would be x to the power 4 minus 2 times 9, 18x squared plus 81 minus 9. So 81 minus 9 will give you 72. So I can say plus 72. This is this is G circle G. Well, the domain of G circle G would be the domain of G intersection the domain of the result. G or real numbers, the result or real numbers, So the domain of G circle G would be from negative infinity to infinity. Let us find the inverse function of this function. The first step is to replace f of x by y, and then to try to solve this equation for x. Notice that we have two terms with x. Now to solve this equation for x, we cross product. So y times 1 minus 5x uh, would be equal to 2x plus 3 times 1, because this is y over 1. Okay, so we have y times 1 is y, negative 5xy would be equal to 2x plus 3. Now to solve this equation for x, uh, take all terms with x in one side. So when I negative 5xy already here, I bring 2x to this side, so it would be negative 2x. And the terms without x, you take it to the other side. So y, I'll take it to the other side. So now I have two terms with x in them. So I take x as a common factor. So I'll have negative 5y minus 2, and here 3 minus y. And now you simply divide both sides by negative 5y minus 2. Notice that this also can be written as negative 3 plus y, or y minus 3 over 5y plus 2 if you multiply numerator and denominator all by negative 1. And now we interchange x and y, and finally we write f inverse of x instead of y. So this would be the inverse function. And you can find their composition, and it should be x, and you can check easily, quick check. If you replace x, for example, by 1, find the result and put the result here. So this is the inverse function. Use the laws of logarithms so to expand each expression. So we have ln x, all of this inside the ln, so product, so it would be ln x plus ln square root of x plus 1. And square root of x plus 1 is x plus 1 to the power half, and then you can take half outside in front of the ln. So this would be expanding the expression. And here write it as a single logarithm. So first I have to take half up, so it would be ln x to the power half, or I can write it ln square root of x minus ln, also this 2 you can take it up, x squared plus 1 to the power 2. And now you have negative, so you can write it as single logarithm, where square root of x is up in the numerator and x squared plus 1 to the power 2 is down in the denominator. Solve each equation for x. Now to solve this equation for x, I will apply ln to both sides. And ln and e cancels each other. So I'll have e to the power x equals ln 10. And then I apply ln again. So ln cancels e, and the value of x would be ln 10. This is the exact. If you want to find a decimal approximation, you just use the calculator and ask for ln 10, and to how many? To 3 decimal places. So it's 0.834. After 4, I have 0. So that's the final answer. And this is the last question. I hope you enjoyed this review about chapter 1.